Okay, ladies and gentlemen, so let's look at the what is that, the slide. So the animation show us about the okay, dua orang listen. Okay, yang baru masuk Alison dengan siapa? Yang baru masuk ni Alison dengan siapa ya? Ada ke Chong Hong Meng? Chong Hong Meng ada dekat sini tak? Tak ada. Okay. So, ladies and gentlemen, let's look at the motion of two trolley. So let's say the two trolley, okay, so we can notice that, okay, we can choose the mass. Let's say both of them with the same mass and one move with 2 ms-1 and another one be moved with opposite direction. Observe what will happen when they collide each other. Okay, so that means that both of them with the same speed, same mass, after collision, they will stop. That will be the final speed. How about if I make it the A move faster? A move faster, that means after collision, both of them combine and move with a speed. So move with a same speed, both of them move with same speed. That means that what type of collision is it? This is an inelastic collision. In the inelastic collision, that means that both of the trolley, after collision, they combine and move together with same speed, must combine. Before combine, they move. So this means in the principle of conservation of momentum, okay, for example, okay, let's go through the external whiteboard. This means that for momentum, the concept of momentum we learned before. To investigate the momentum, we use the principle of conservation of momentum. Here, the principle of conservation of momentum can be applied in 3 situations. That's apply in 2 situations. What are the 2? That means first is the collision. Another one is the explosion. In collision, we have inelastic collision, and we also have elastic collision. Okay, this means that what are the difference? For elastic and inelastic collision, the similarity before collision, that means that their motion will be like that. Okay, both move or one move, one stationary. Okay, both move or one move, one stationary. Okay, in any direction. Explosion, explosion will be stationary before explosion and after explosion. That means that it will move in opposite direction to each other after explosion. Okay. In elastic collision, that means that after collision, in elastic, that means combine and move. Same speed. And elastic collision, after collision, that means that they will move separately. Okay, can be moved with the same speed or can be moved with the different speed. Okay, normally different speed. Okay, that means that after collision, okay, after collision for both, they can either one move, for the elastic collision, either one move, one stop, or both move. But in elastic collision, it also can be either one move, one is stationary, or both of them are moving. If both of them are moving, that means that one of them are moving, that means it can be moved in any direction. Remember, momentum is a vector quantity. That means that momentum have the magnitude and also the direction. Any velocity in opposite direction, any object move in opposite direction, its velocity will be negative. Let's back to the animation. Now, if one of the objects stop, how about this is the velocity? We look at the velocity time graph, yeah. Okay, so that means that after collision, they move. How about the momentum graph? So we look at the momentum. Still, is it where you show me? Okay, the direction of the momentum. Okay, so that means that no matter how is it, the momentum is bigger, right? After collision, it becomes smaller, and here zero becomes something. So again, we look at if I use negative for both of them. Okay, you see? In opposite direction, at the end, the momentum becomes zero. If one move bigger, smaller, after collision, both of them, this one becomes smaller, this one becomes bigger. Okay, now we go to the next slide. Just now we observe the velocity against time graph. Now we observe the momentum time graph. So now we look at here, let's say the object move. One moving, one is stationary. After collision, the momentum of the trolley A reduced, the red color. And the blue color, the momentum increase. The green color show that that is the total momentum. Okay. So again, we notice that if trolley B move with greater speed, after collision, they will move in opposite direction, red and the blue color. But you notice or not, the green color always constant. Okay, the green color show that always constant if the mass difference, although it's moved with greater speed. Now we look at what will happen. That means that no matter how, the total momentum, the green color line, still always constant. Now we compare the kinetic energy. Let's say two trolley is moving. Before collision and after collision, the momentum before collision is 2 kgms -1. That means for the A and B, yeah, total momentum. Total momentum after also 2 kgms -1. So is the momentum conserved? Conserved means that before collision and after collision are equal. Momentum. Is momentum conserved? So should be yes. Ladies and gentlemen, okay, here, if we just mention momentum conserved, actually is not correct actually. So what we need to write in exam. In exam, we must mention total momentum before equal to the total momentum after. So should be total. Is total momentum conserved? So the total momentum is conserved. But if just momentum only, momentum not conserved. Okay. Momentum only means that momentum for one of the trolley. No, should be total momentum conserved. Why? Still remember just now. Okay, let's see the motion again. Look at the momentum. Let's say okay, A. We notice that A with greater momentum, after collision, it becomes smaller. Is it? So for trolley A, before collision, look at the size of the error. The error reduced. The error show the momentum. Then B, look at the small error after collision, change the direction. So from negative to positive. So that means that the momentum changed. That means that, but both of them combined, the total momentum of A and B are conserved. How about kinetic energy? Kinetic energy for A and B, 1/2 mu square of A. Total kinetic energy plus with kinetic energy of trolley A plus with the kinetic trolley of any trolley B will be difference. Total kinetic energy before and total kinetic energy after collision are different. So that means that we said that the kinetic energy not conserved for inelastic collision. Now we can make, let me see, we can make a conclusion. It's useful to consider idealized motion for which we ignore the effect of friction. That means that in the collision, just now the situation, we ignore all the effect of the friction. We ignore any of the external force. Just focus to the trolley A and trolley B only. Next, velocity and momentum are vector quantity. So momentum of a body is the product of the mass and velocity. P equal to mv, unit SI unit should be kg ms -1, and spatial unit Newton second. In an elastic collision, the body stick together after collision. Okay, so they combine or they lekat together and move with a same velocity. And total momentum, you see, total momentum is always the same before and after any collision. We cannot write momentum is always, no. We must write total momentum is always the same before and after collision. This is an example where principle of conservation of momentum apply. And ladies and gentlemen, for the kinetic energy of a body also depends on the mass and velocity. So kinetic energy, we use 1/2 mv squared. So momentum is conserved in all collision, remember. But total momentum is conserved in all collision. But total kinetic energy is not conserved in elastic collision. Okay, remember total. Okay, now let's go to the next situation. So there is elastic collision. Let me see. For elastic collision, no matter how, after collision, both of them will move with different speed. Okay. If like this, you see after that the blue and red color, they will move in opposite, okay, opposite direction. Okay, no matter how, here we just consider, okay, consider two systems. That means that after collision, so they will move separately with difference, sure must be different speed. Okay, impossible they will move with the same speed. They just will move with the, impossible they move with same velocity, but they maybe can move in the same speed. For example, yeah, you see, okay, if 3 kg move in 2 ms -1 and 3 kg move in opposite direction, they can be moved with the same speed. That means that same initially, okay, initially the red is 2, after that become -2. So final for the blue color, initially -2, after that 2. They can be moved with the same speed but different velocity. Okay, next, Next slide show that the graph of the momentum. Before same thing, before collision and after collision, the green color, they will be always equal. Let's say like this. Before collision and after collision, the green color always equal total momentum before collision and total momentum after collision always constant. Next, in this chapter, mostly we need to observe, we need to compare the kinetic energy. Before collision, the total kinetic energy is 2 joules. After collision, the total kinetic energy of B is 2 joules. You see, initially A is 2 joules, final it becomes 0. B initially 0, but final become 2. So that means that here, is it total momentum? Not momentum, yeah. Is it more total momentum conserved? So yes, total momentum before collision and after collision are conserved. Kinetic energy before and after conserved because they are equal. Okay. As a result, as a summary, we can say that total kinetic energy is conserved. They are called perfectly elastic collision. Momentum is always conserved. Ladies and gentlemen, this is total momentum is always conserved. Okay, and velocity of approach v1 minus v2, velocity separation v2 minus v1. Okay, so perfectly elastic collision, velocity of separation of the tracks is equal to 0. That means that for any perfectly inelastic collision, the velocity separation, okay, is always equal to 0. And in perfectly elastic collision, velocity, if elastic collision, the velocity of separation, that means v2 minus v1, final, yeah. Okay, so velocity of approach and velocity of separation. Okay, no matter how we use the big minus the small one, the big one minus the small one, so we get that the velocity, okay, before, the difference in the velocity before and difference in the velocity always equal. Okay, just for inelastic, v2 minus v1 equal to 0. Okay, so that means that momentum is conserved for all type of collision. Total momentum is conserved for all type of collision. Okay, now if we compare both of the, okay, or various type of the collision, now we look at here. If we use the, we notice that after collision, they combine and move together. This is the, what is that? This is the inelastic collision. Okay. Okay. Here we have a constant of C. What is the meaning of the constant of C? Okay. Okay, this one we call that this is the coefficient E. That means that this C, right? Where is my pen? Yeah. This one we call that, we use a symbol where E is equal to coefficient of restitution. If we found that the coefficient, that means that actually it's like that. Okay, I use external slide, yeah. From here, the E is equal to coefficient of restitution. So from here, how to get the coefficient of restitution? So the formula should be like that. V1 minus V2. Okay, because initial final, right? Equal to the coefficient of restitution times with U1 minus U2, the speed. So that means that E will be equal to V1 minus V2 over U1 minus U2. The difference in the final velocity divided by the difference of the initial velocity. So that will be the E. Sorry, here we'll have one negative. Okay. So from here, this is negative E, yeah. So that means that it will be negative V1 minus V2. Okay. So that means the formula should be like that. Ladies and gentlemen, if we get that E1, we will get the E1, E either equal to 1 or E less than 1. Okay, E equal to 1 or E less than 1 only. If E equal to 1, that means that it will be perfectly elastic collision. If less than 1, that means it's in inelastic collision. Okay, so that means that we can compare the value of the coefficient of restitution. Now, back to the slide. Just now, if it's 0.8, 0.8, that means not equal to 0, right? So that means that, okay, the C coefficient, okay, coefficient if equal to 1, that means that it will be total inelastic collision. Okay. So if 0.8 is okay 0.8, that means that 0.8 is less than 1. So that means it is, although we notice that they move in a difference, right? But it's not the perfectly elastic collision. Okay, so if 0, we notice that after collision 0, okay, less than 1 or less than 1. Let me see. 0 is the inelastic collision.